Hey there young makers, welcome to the 8th episode of Arduino tutorials with Witblox. In our last session, we extracted values from a dark block and displayed them on your computer screen. Continuing the same concept, today's session will be extracting values from a distance sensor and we are going to create a new project on it. So dark blocks is all about LDR. But our distance block contains a very awesome sensor which is practically used almost everywhere in our lives. Be it your lift, your phone, even your parking sensor of your cars. The sensor is a photodiode. No, not at all. Please stop. Let me explain right from the basics. Electricity needs a path to flow. If a material allows electrical charges to flow through them, we call them conductors. Example, copper, aluminum and graphite. If a material is arrogant enough to not allow the charges to flow through them, we call them insulators. Example, wood, ceramic, etc. Now we take these conductors, mostly carbon, and mix them with insulators, mostly ceramic. We can control the conductivity of the newly formed mixture. This mixture is used to make resistors. So a resistor is basically a conductor with reduced or controlled conductivity. Well, LDR contains cadmium sulfide whose conductivity increases in presence of light. Since light controls its resistance, it is called as light dependent resistor. Now there are certain elements in our periodic table which are neither conductors nor insulators but are too selective about their approach. They will place conditions to become either a conductor or an insulator. Such type of special elements are called as semiconductors, and the most basic semiconducting device is called as a diode. Now there are different types of diodes. A basic diode will simply get heated up when current is flowing through it. A light emitting diode or an LED, well, it emits light. And then there is photodiode. A photodiode will allow charges to flow through it from one side only, as a normal diode would do. But from the other side, if the charges receive energy from IR, then only the charges are allowed to move through that side. This is the very feature of photodiode that we are going to harness. In our distance block, there is an IR module connected to it. The IR module contains an IR LED, which is a diode but emits IR rays. The second is the photodiode. The IR LED continuously emits IR rays. Now whenever a user places an object in front of the IR pair, IR rays bounces from the object and falls on the photodiode sensor. As our photodiode is sensitive to IR rays, it will allow charges to flow through it internally. This is detected by the brain of our distance sensor and compares the value with our knob. Depending upon the result of the comparison, the distance turns on or off the output. Now this photodiode is connected to the analog out of our distance block. So let's read its value. This is the circuit diagram. Let's save our program with the name distance analog read. Let's define our distance block. So before void setup, we go and define our distance block at A0. Also, let us define a variable which will store the value of distance block. So we'll say integer sensor value is equal to 0. In void setup, we have distance as an input. Also, we'll define our serial monitor. Next, in void loop, let us read the sensor value. Now we want to print this value, so we will print using serial print. We'll have a small delay. Last time we used 1 second delay, this time we'll use 500 millisecond delay. Let's upload this and check the result. One thing to note over here is the value of photodiode reading will always remain within a particular range. It will not go beyond this range of 30 to 850. That is the question that I want you to explore. You guys explain me why we are getting this range only. Shoot your explanation video and share with us on Witblox app. Now let's add our map function so that our values become a bit sensible. For that, let's define a variable. Sensor map value. This will hold the mapped value of our sensor value. Next, in void loop, sensor map value will contain the sensor value. The range is 30 to 850. Why I have kept this 30 to 850? Because that is the value which normally we get as the bottom and the top range. It may change from user to user. Let's finally print them. So we'll write sensor map value. Let's upload and check the result. Well, a normal distance block says, if anyone comes within my range, I will turn on. I want to tweak this. I have created this project. This pendulum needs to remain exactly at this position. If it goes towards the sensor, the buzz is on. If it goes away from the sensor, the buzz is on again, but remains off only when it is maintained at this position. If anyone who is able to maintain this position for a very long time, we can say that the person is having a good amount of patience. Now let's see the circuit diagram first. We have connected analog out of distance to A0 and a buzz on pin 7 of our Arduino. Rest all you know. We will edit the same previous code. So first, save the program as Patience Analyzer. Next, let's define our buzz. Integer buzz. Our buzz is an output. So we'll have buzz as an output. Rest all will remain as it is. Let's go to void loop. Let us first remove this delay. We do not need this delay right now. Next, we will compare the value of sensor map value. If sensor map value is less than some value, so we'll write if sensor map value is less than some value, or more than some other value, then turn on the buzz. Else, keep the buzz off. See, I have mentioned all these things in a comment. So this is ignored by our Arduino program. So how do we write these in a code form? We will write in this format. If sensor map value is less than 30 or sensor map value is greater than 60, then what should happen? It should simply turn on our buzzer. Else, keep the buzz off. That's it. This is the code. Over here, these two bars, where do you find these bars? It is above your enter button, using shift and the button above your enter button. So these bar is called as logical OR. We have some logical operators that we are going to extensively use in our sessions. Logical OR means either first part should be true, or the second part should be true, or both of them should be true. In any case, this entire statement becomes true. So if this entire statement becomes true, this part of the code gets executed. If none of these parts are true, then this part of the code gets executed. Let us upload and check the result. In this project, we have installed the IR to the end of the board. To this, there is an L-shaped stand to which a bulb is connected like a pendulum. The distance between the IR and the pendulum bob is placed in such a way that the bob is always within the range of the IR. So I hope you enjoyed this session of Arduino. Do try this project, do some modifications and share its video on Witblox app. I am curious to know how you guys do it. Till then, stay safe and happy inventing.